Myth. Free fall acceleration is normal in skyscraper collapses.
And in just a moment, we'll bring Kamal up here. But let's listen to David Chandler, who's done an excellent analysis on just how fast this building came down. This is the analysis that forced NIST to acknowledge that the building came down, in fact, at free fall. Before this, they were denying that.
We can measure the downward acceleration of Building 7 by video frame analysis. I used a magnifying glass to place markers on the corner of the building on each frame. From this, we can get a data table and various graphs. The slope of this graph indicates acceleration, which is shown here to be about minus 10.279 plus or minus 0.6. Free fall in a vacuum is minus 9.8 in these units. That falls within the margin of error of this measurement. In other words, the rate of fall of Building 7 in the first few seconds is indistinguishable from free fall in a vacuum.
This brick that I'm holding in my hand is falling at free fall acceleration. 3, 2, 1. Why? Because there's no resistance underneath it. We can see the building gaining downward momentum with each second, increasing distance. That's the definition of acceleration. There's no resistance from the columns to the force of gravity. What happened to the 40,000 tons of structural steel in this building? To help us answer this question, I'd like to invite up today a structural engineer, a very special one of 40 structural engineers signed on to the petition at AE 911Truth.org. He has 30 years of experience in the design, analysis, and construction administration of structural steel and concrete buildings and other structures. He served as engineer of record on over 100 structural steel buildings, projects of varying sizes and complexity. He conducted linear and nonlinear dynamic analysis and potential failure analysis of multi-story steel frame buildings. He received a Master of Science in Civil Engineering at the University of California in Berkeley in 1980 and his Bachelor in 1978. He's a registered California Civil and Structural Engineer. Mr. Kamal Obeid. Kamal, welcome.
Thank you. Is this working?
It will be. We'll bring it forward to you.
Okay. Okay, thanks, Richard. Just wanted to point out that for structural engineers, and I'm glad actually there's 40 now signed up. That's actually pretty pathetic, I would say.
We need about 200 more.
But for structural engineers, what really gives this away is Building 7. I think it's a classic case of what looks like controlled demolition. And no matter how you look at it, in fact, it's just makes it's just too obvious. But anyway, what I'd like to do is actually talk a little bit about the structure of that building, hopefully not to bore you too much. But do I have my slides? There, yeah, thank you. So here's the faces of this building. This is taken from the NIST report, which is what was used. The NIST report is the huge document that was put together. It's quite a piece of work, actually. It's a 9-volume document. I don't know how many thousand pages it is. It took 7 years to put together, maybe 8 years, I would guess. And they came up with an explanation of how this building collapsed, and it's actually very interesting. And I think every structural engineer should look at this thing and basically judge for themselves. But anyway, this building, it's the faces of this building, the outside faces are the 4 diagrams that are shown on the top of the slide. And what's important about this is that the faces of the building are all interconnected with steel beams and columns. And it's actually, think of it, and I want to use that analogy, like a beer can, essentially. It's a big, huge beer can with perforations in it. So it performs like a beer can in a way if the building is failing. The inside core of the building up to the 7th floor is actually very rigid with frames and it's another tube structure within a tube. And the structure is so strong up to the 7th floor that this building was actually built over a Con Ed power station. And at first it was thought it was a weak point of the structure, but then I guess NIST couldn't even prove that the building failed at the bottom. So essentially, what the story turned to, they started looking for how the building would fail at the upper floors, and that's what we want to get into. So let's go to the next slide for a minute. So I'm going to talk about this really briefly because it's highly technical, but it's very important. So this is the framing of the 12th floor up. So they're all similar floors. You have beams that are running horizontally connecting to columns, and they support the floors on the building. So the culprit, according to NIST, is column number 79, which is right there. And the concept here is, the theory is that these beams right there, during a fire on multiple floors at that same location, actually expanded, just like Richard was saying, and in fact pushed this girder, which is connecting the column outside column 44 to column 79, and actually pushed it off its